there's like a bunch of different lines, right? We got one over here, 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 and there. So can anyone tell me what any of those represent?
Are those like the ranges and domains?
Not specifically those things, but there are, keep thinking of those vocab words we know.
Mean, median,
Mean, median,
mode.
we know mode, and there's a couple more that are specific to box plots.
I think I forgot those ones.
Okay, does anyone else remember? Let's take a look at the blue ones I have highlighted. Just the blue ones, not the purple ones. So the blue ones, can anyone guess or do they know what these represent? There's one on the 5 and there's one, oops, on the 17. Can anyone tell me what that means?
Does it start with a W?
Mm-mm. Look at the answer choices. What do we notice about the answer choices? The 5 and the 17, what is that?
Wait, you asked what the blue parts are?
The 5 and the 17, that's what I said.
The minimum and maximum?
Mm-hmm. The minimum and the maximum. Now, does that help me eliminate any answer choices?
No, they're
No.
already all in between 5 or 17.
Yeah, so those are all fine for everything else. But what about the 3 lines in the middle? The purple ones. Can anyone remember what those are called or what they represent?
Perla wants to do it.
Miss, you asked for the 3 lines in the purple, right? Aren't those the quartiles? Whatever.
Yeah, good. Those are my quartiles. So I have quartile 1, quartile 2, and quartile 3. But Q2 has a different name. Does anyone remember the name for the more common name for Q2?
The median?
Good, the median. You got it. Okay, now we have everything. So we know that the maximum is 17, the minimum is 5, Q1 is 7, the median is 11, and Q3 is 14. So now we have to find which one of those matches. Does anyone have one that they think might match that we maybe could look at? Any of these answer choices?
Maybe B?
Let's check out B, sure. Okay, so first thing we check is, are they written from least to greatest?
Yes.
Yeah,
Wait.
so we're,
Yeah.
5, 8, 10, yeah, we're good. Okay, then we're gonna start labeling things. Matter of fact, let me just write the numbers over here. Okay, my minimum is 5, my maximum is 17. How do I find the median? Oh, oops, yeah, this is 9. How do I find the median of this set of numbers?
If there's 2 middle values, like if there's an even number, then you would add them and divide them by 2. But if there's 1, which, no, there's not 1, so we have to add 10 and 12. Yeah.
Okay, yeah. So there's 2 values in the middle. I've crossed everything else out. So I'm trying to figure out what's right in between 10 and 12 And in order to do that, sometimes it's easy, but sometimes you might want to do the trick that Perla said, which is that you got to add them together and divide by 2. So what's 10 plus 12 divided by 2?
11.
11. That is my Q2 slash median. So far so good. Well, now I need to find my Q1 and Q3. Does anyone remember how to do that?
Wait, miss, can you repeat that?
How do I find my Q1 and my Q3? Once I have the median, because that's always what you have to find first. When you have the median, you can continue on. So what should I do? Well, Q1 is the median of the left half. So I'm going to look at everything to the left, so all of these numbers, and find the median of those, which we already know we can do, right? We're finding the median. So it's going to be between 8 and 10. What's between 8 and 10? 9. That's my Q1. And then I do the same thing on the right side. Both of these are 13, so the median of that is still just 13. That's Q3. Now, does this match? Do I have a match? No, we were close, but not quite. Unfortunately, the Q3 is wrong, so it's not B. But let's try another one. Does anyone have a different one that they think might be right?
D?
C?
I said D.
Oh, you said D. Okay, let's do D. Okay, first you go for the middle, the median. What's 9 plus 13 divided by 2?
22.
Divided by 2?
11.
11. So far, so good. Now we go, let me erase all my markings. Now we go and find the median on the left side. So again, I do this. Here I get 9. And then on the right side, same thing. What's between 13 and 15?
14.
14. We have a match. 9, 11, and 14. That's it. Questions on how to find Q1, Q2, or Q3? Now it's going to be different depending on how many numbers are in the set, because sometimes when you have an even number of numbers, things get, we gotta be careful. So we'll do another example in the next slide. All right, so here we got another box and whisker plot. John has collected 523 baseball cards. Which statement must be true about John's number of baseball cards? So if John, he's one of the kids who collected cards, if he has 523, is it in the third quartile? Is it the mode? What do you guys think?
Wait, miss, I have a question because I'm kind of confused.
Mhm.
From 125 to 314, that's the first quartile, right?
You got to be a little bit careful. Let me explain. That's a good question. Let me just draw just a sample. Okay, so here's just a random box. We have 4 quartiles. This line is called Q1, but the first quartile is that section. And that quartile represents 25% of the data. So 25% is in there. Then you have Q2, right? That's Q2, but this is the second quartile. And again, there's 25% in there. Then it keeps going, right? So even though Q1 is that line, really it's representing like the end of the first quartile, not the beginning of the first quartile. Does that make sense?
Okay, thank you.
You're welcome. All right, here's the last one. So I'm just kind of labeling this now. And every quartile, every little section of the box plot holds 25% of the data. So for example, and I'm not really looking at the question yet, but which quartile is this referring to? 25 to 50. Where is that?
From quartile 1. Oh wait, no.
From quartile 1 to?
Oh,
Quartile 2.
Yeah, from quartile 1 to quartile 2. Where is the 50 to 75 range?
Isn't it from quartile 2 to quartile 3?
Exactly. So what's our answer? 523, which quartile is that in?
Quartile 2?
523,
I think it's 3.
right about here, right?
Yeah.
Somewhere around here. So that's going to be inside of the third quartile, which is the 50 to 75 range. Okay, so that was a really good question, Perla, because I think that could be a little confusing. So I'm glad that we went over it. Okay, well, I think I have one more. Yes, so we'll practice the whole calculation one more time. Which data set has the greatest interquartile range? So IQR, who remembers what that is?
You're asking what's IQR?
Mm-hmm.
Don't you have to like subtract or add the quartiles?
You're on the right track. You're going to subtract. So you would do Q3 minus Q1. That's your IQR. So it's basically like how much is in that middle 50%. So let's check it out. So we have to figure out which one has the greatest IQR, right? So I have to find the IQR for all of them. But before I do that, what has to happen first for each of these?
We have to put them in order.
Put them in order, exactly. So help me out. We got 0, 1,
3,
3,
4, 7, 7, 8, 8, 9.
Okay. Cool. I start with my median. Remember, that's always the first thing you look for is the median. I got it. It's this 4 right here.
Wait, there's 4 on one side and there's 5 on the other, miss. It's 4 plus 7.
Oh, you're right. I counted wrong. Thank you.
So it's 5.5, right?
So hold on. 0. Now let me do it this way. See, sometimes when you take shortcuts. Yes, you're right. So 4 plus 7 is 11, right? And then 11 divided, yeah, so 5.5. That's my Q2. And now I find the median on the left and the median on the right, including the 4 and that 7. Just don't forget you include those. So on the left, I have 3. And on the right, I have 8. I didn't have to do the thing where you add up and divide because there's an odd number of values, so it's right in the middle, the 8 and the 3. So what's my IQR for algebra?
5.
5, good. And now we got to do it to all of them, so let's go right along. I've got more numbers here, so I hope I fit them all.
1,
1,
2, 3, 5, 6, 7, 8, 9, 11.
perfect. Okay. Median. What's between 5 and 6?
Oh. Wait.
5.5.
Mhm. When I look for Q1, do I include that 5 or not?
Include it.
Good. Okay. I get 2 right in the middle. I get 8 right in the middle. What's my IQR?
6.
For chemistry, what do I get?
6.
6. Again, these types of problems, you just gotta keep it up. Do it again and again and again. 0, 1. How many 2s do I have? 3?
Yeah. And then a 3, a 4, a 6, a 9, and a 10.
Beautiful. Okay. Median. Is between 2 and 3, which is what?
2.5.
2.5. Do I include that 2, yes or no?
Yes.
Yes, ma'am. Okay. What's my Q1?
2,
Good, it's right in the middle.
and then 6, 4, 3.
Okay, so 6 minus 2 gives me
4.
4. Last one, maybe it's US history. Let's find out. Zero, 0, 1.
2, 2, 3, 4, 5, and then 7.
And 9.
Ooh.
Okay. Median. $2.5 again. Q1.
1.
1. Q3.
5.
5 minus 1.
4.
4. So who wins?
Chemistry. Yay.
Chemistry.
Oh, I wanted algebra to win.
Me too. Now, very quickly, because I didn't see an example like this, so I just want to list some random numbers. Hold on. Mm. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say those were my numbers. And I was looking for the median. 7 is my median, right? And then I was like, okay, now I need to find my Q1. So I have to look to the left. Should I include that 7? Yes or no?
Yes.
I think no.
Wait. No.
I think no.
No, you can't. Because if you can't include the 7 because it's right in the middle. So when your median is one of the numbers, when it's an odd amount of values, so there's a number right in the middle, we're not going to include it. Oops, we're not going to include it when you look for Q1. So my Q1 would be 3. Same thing on the right side, we're not going to include that 7 because it's right in the middle. So this would be 11 Q2 or Q3. So that's the only thing to just like be a little bit careful about. So if your median is one number, it's not in between anything, it's this smack in the middle, you do not include it when you're calculating Q1 and Q3. When it's between the two middle numbers, you do include those numbers on the left and the right. Any questions on that?
No.
All right. By the way, I apologize. I don't know if you guys can hear, there's construction going on in the
No, I
house.
can't hear anything. I don't know if it's just me being deaf.
Yeah, I can clearly.
Okay, good, because it's pretty loud for me, so I'm like, oh no. All right, guys, last day, officially.
Woo woo!
Woo! Woo! Here we go.
Unless we're all so nervous.
I know you guys are, but don't worry. Trust me, you guys are gonna do amazingly.
Hopefully.
For real, I'm so nervous.
So yesterday we did dot plots, histograms. We've remembered like mean, median, mode, all of those things. Today we're gonna finish statistics with the last two types of graphs. So this is a frequency table. We're gonna be doing frequency tables as well as scatter plots. All right, so here we go. Frequency tables. Frequency tables tell you how many people or how many things fit into each category. So in this case, students were asked to name their favorite sport, and it looks like they divided it between girls and boys, which is honestly not inclusive. They should include more options, but you know, it is what it is. And so here are the answers that everybody gave. And then it asks what percentage of the students chose soccer as their favorite sport. So how many students chose soccer? How many total students chose soccer?
Wait.
99.
How'd you get that?
I just added 58 plus 41 and I got 99.
Good, because we have, it's split into boys and girls, but it's asking about all the students, right? So we have to add it up, we get 99.
Now I have to
99.
convert it.
Yeah, but we need to know what percentage of all the students. So does it tell us how many students answered the survey?
No, we
No.
had to find it out ourselves.
By
We're gonna
adding.
figure out. Yeah, we got to add things up to get all our totals. So sometimes the table doesn't have a totals column, so you have to do it yourself. So let's find all our totals.
Tennis is 25.
Which one?
Tennis.
Oh, tennis, yeah. Tennis is 25. What about basketball?
126.
26. Good, Jalen. All right, now we got to add across so that we can get the total. Thank you, Perla, for that reminder. Yes, on Monday when you guys go into the school, you have to be wearing your uniform. Thank you. Red
Or else
shirt.
they would get
Though
you.
I honestly, if you don't have one with you and don't stress about it, maybe wear a different color if that works for you, as long as it's a collared shirt, a uniform type of shirt. Yeah, also your ID, again, don't worry too much. I can ask Mr. St. Rose just to make sure that he knows who you are and he will make sure that you get in without a problem.
No, Miss Lopez, I don't think I don't think they check because, well, at least when I come in, since I go straight to the office to do announcements, they don't check me, but the
Yeah, they
tables
don't.
are separated and Mr. Joseph is always there, so you guys can just tell him that you guys just came to take the EOC and you guys are normally online students. I'm sure he
And
won't.
there's going to be a list with your name on it, so they'll know that you're taking a test. And Mr. St. Rose will be in there. I'll have my phone with me so I can communicate if you guys need help, okay? All right. So what did we get for my total? My grand total. $126 plus 99 plus 25.
250.
250.
250. Dang it, Perla.
Ah,
So how do I get this percentage? I need to know what am I gonna divide?
Miss, you know I have such an odd way of finding out percentages.
What did you do?
I would like normally, since I'm not really good with percentages, I would normally find like what is 10% of a number.
Mhm.
So like for example in 250, 10% would be 25, right?
Mhm.
So I would be like um 25 times 3 is 75. So that's already 30%. I would just find out in a weird way.
That's a very
It would
that's a
be
very long-winded way. There's a much faster way.
yeah, I don't
How many
know.
students chose soccer? How many?
99.
How many students are there total in this whole school?
250. That's really low.
Well, that's how many they asked, right?
Oh yeah.
99 out of 250. What's
Oh, I'm
99
done, miss.
divided by 250? Use your calculator. 99 divided by 250.
0.396. Emily beat me to it. Oh man.
Haha.
Which is a decimal. So now let's turn this decimal into a percentage. What would it be?
Hey.
Ms. Lopez, I have a question.
Hold on, finish this problem. What's my
Oh,
final answer?
39.6.
Thank you.
Put the decimal points two places to the right.
Okay, what's your question now?
For the EOC, will we have a calculator part?
Yes.
And will they give us our own calculators?
No, you have to bring your own or use the one on the computer. Same
Oh,
as a
okay.
topic test. You know how the topic test has a calculator button?
Yeah.
You can use that one.
And we use our own paper, right?
Probably, yes. Matter of fact, and I'm going to go over some of this stuff on Saturday and Sunday. But yes, bring your own paper because I'm not so sure what they can and can't give you. So I'm not entirely sure if they're allowed to give you paper because of the restrictions. So bring your own just in case.
Okay, thank you.
All right, next one. All right, sometimes you're going to have to fill it in. So let's read carefully. Students at a high school, actually, who wants to read? Tyrone,
Sure.
go ahead.
Students at a high school were asked if they had attended at least one of the high school's football games this season. The responses are shown in the table. Of the students who responded that they attended at least one game, what percent were seniors?
Perfect. All right, so seniors, how many are there?
There are
500.
Good, we had
wow.
to add 500. And then it's saying of the students who responded that they attended at least one game. So how many students responded that they attended at least one game? We're going to have to do some math, right? What am I
Yes.
adding?
1,600.
So you added 350 plus 400 plus 400 plus 425?
Yeah, I kind of did it backward. I did 425 plus 400, 825. Oh, wait, no. 1,575. Never mind.
1,500
500. I thought that was a 50, miss, for the
and
seniors.
75.
Wow.
That's what
okay.
happens when I rush.
That's okay. 1,575. Okay. Well, now let's read this again. Of the students who responded that they attended at least one game, how many is that? That's 1,575. What percent were seniors? So out of those 1,575, how many were seniors?
425.
Good. Those are our two numbers we look for. So it's always, you got to make sure you're picking the right numbers. Now we divide, same as we did before. This is 425 out of 1,575. What's 425 divided by 1,575?
It is 0.269841269. You get the point.
2698, you said?
Yes.
Okay. And let's go ahead and round that to the nearest whole percent. So as a percentage, what is that?
26 point or 27, I guess you could say.
Yeah, because we're going to round to the nearest whole percent. So that would be 27%. Questions? This is all about reading carefully and picking the right two numbers. So any questions so far?
I have a question.
Go ahead.
Will Perla ever stop stealing my answers?
No is the answer to that one.
It's the other way around, actually, so don't make yourself the victim. But okay.
Okay, now here's a hard one because now they tell you some information and you have to use it to fill in the blanks. And I know for sure there's going to be one like this on the test because I've seen it. Not that I haven't seen this year's test, but I saw it on last year's test. All right, so here we go. A survey of 525 people was conducted to determine whether or not they have brothers and sisters. The results showed, here we go, this is where we highlight, that 24% of the people surveyed do not have a sister. Let's start with that. 24% of the people surveyed. How many people were surveyed?
100. Wait.
525 people.
525 people. So we're looking for 24% of 525. So here's what we do. What's 24% as a decimal?
0.24.
0.24. The word of means multiply. What's 0.24 times 525?
126.
126. So 126 people do not have a sister. Questions on how I did that? We'll do it again and again, but do I have questions right now?
No.
Cool. 68% of the people surveyed have a brother. 68% of the people surveyed. How many people were surveyed?
525.
525. So again, 0.68 times 525. What does that give me?
$357.
357. 357 people have a brother. So where's that going?
Uh, right there.
Where's there?
5.8.
Real. Annotate.
No.
Which column? Describe it.
Uh,
Perla.
wait, the columns are the ones that go up and down, right?
Uh-huh.
The second one, I mean third one.
The third
Right.
one down at the bottom?
Yeah.
So here?
So no. The one above that one.
Which one? Where?
The one where it says do not have a sister.
Do not have a sister. So in the same place over here?
Do not have a sister and do not have a brother, I think.
So here?
No. Do not have a sister, have a brother.
So here?
Yeah. Oh
What?
no. The
Oh
first
my
one.
god. This is why you should have just annotated.
Where?
The first one. The one.
Here?
Yeah.
Okay. But read it
I
carefully.
knew.
68, again, what did I highlight in green? 68 of the people surveyed have
Oh,
a brother.
total.
It's the total.
Oh,
It's the total.
okay.
Read it carefully, okay? I'm going to line that up a little better. There we go. Okay. All right, continuing on now. second bullet point. The results also showed that 39 of the people surveyed. Is that a percent or just a number?
Number.
So 39 people do not have a sister and do not have a brother. Where does that go?
Where it says do not have a sister, do not have a brother.
Okay, so right here.
Yeah.
Good. All right. Now we have enough information to fill in some more stuff. What can I fill in next?
The one that says do not have a sister, have a brother.
Okay, so I have to do 126 minus 93. What's 126 minus 93?
33.
33. What can I
And
do
then we
now?
can fill out uh, fill out the one on top by doing 357 minus 333, which is 314. No, 324.
324.
Yeah. Oh my god, I can't subtract and add.
All right, what else can I fill in?
Oh, the do not have a brother total.
Yeah, do not have a brother total. Yeah, so 525 minus 357. What's that?
Miss, can you repeat that? You lagged out.
168.
Oh, never mind.
And then we can do the other one.
Yeah, fill out the rest.
Okay.
How many people have a sister but do not have a brother?
75.
Mm-hmm. And finally,
So 324, 399. Oh, you
399.
beat me to it.
Good job, guys. Any questions on how we filled in all of this info?
Wait, miss, now I have another question.
Mm-hmm.
So they told us that 93 of the people surveyed do not have a sister. So how do I find out what percent is 93 people?
Of the total?
Yeah.
So you would do 93 people, right? Out of, let me use my 93 out of 525, dividing 93 divided by
Oh,
525.
okay.
Now you're always going to be able to calculate tip, right? Next time you go to a restaurant, which hopefully is not anytime soon.
Well, guess
Okay.
what? I already went to a restaurant. Haha.
That's not something to be proud of, mister.
Well, there
I
are
have
barely
nothing.
any people there.
Still, there are waitresses and waiters serving your food who are being exposed by you.
You're right.
Mm-hmm. All right. The relative frequency table shows the type. Okay, so here's a keyword. This is not a regular frequency table. This is a relative frequency table. I'll explain it in a second. Shows the type of ice cream chosen by 50 people at a party. Approximately what percent of the people who chose vanilla were women? Okay, so a relative frequency table is a little bit different because what it does is it shows you the percent of the total. Okay, the percent of the total. We know that there were 50 total people. So for example, where it says 0.06, that means 6% of 50. How do I get that number? 6% of 50.
We do 0.06 times 50.
Good. And what do you get?
3.
3. So 0.06 of the 50 people means 3 people are men who like vanilla. Okay, so it's kind of like those numbers in the table are the percentages. So if you want to know how many actual people out of 50, you have to convert it, okay? So now what's this asking? This is saying approximately what percent of the people who chose vanilla are women. Who are the people who chose vanilla? How many or what percentage is that?
The 0.06, 0.08, and 0.14.
Okay, so all of that, how much does that equal? You can add them up.
0.28.
So what percentage is that?
Wait, what do you mean?
So 0.28, how do I write that as a percent?
Oh, 28%. Oh,
Mm-hmm. So that's 28% of 50. So again, we do 0.28 times 50. What do we get?
Miss,
That should be
that's
an
a
8.
25.
Sorry.
14.
14. So 14 people chose vanilla. But then we have to see how many of those were women. So now I go back. How many of what's the percentage
8%.
or the decimal? Good. That's this number right here. So that's going to be 0.08 times 50. What do I get?
4.
4. So now we have my two numbers. 4 out of 14 is what?
Wait, Miss Lopez, I just realized that 2% is 1%. Okay, sorry. That gives you
Did you say
wait,
the
I
answer?
got
I didn't hear
4.
you.
Never mind, that's wrong.
4 out of 14. What's that as a decimal?
0.2857142857. So 28.6%.
Exactly. So that would be answer choice D, round up. So this is a little bit more difficult because before you can get your final answer, you have to go from the percentage to the actual amount of people, get your two numbers, and then divide. Questions on this one? Okay. More. Who would like to read this one? My voice is going away.
I will read. Tyrone doesn't want to read anymore. It's a privilege, Tyrone. Okay,
I'm just giving y'all a chance. So rude.
no. Okay, I'll read.
Go ahead.
A random group of high school students was surveyed. Each student was asked whether it should be mandatory for all high school students to participate in a sport. The results are partially summarized in the two-way table. In the freshman group, what percentage of students agree that it should be mandatory for all students to participate in a sport?
Awesome. So I'm looking only in the freshman group, which means I need to know how many freshmen. How many freshmen do I have?
Oh, don't we have to add
Mm-hmm.
19 plus 53 is 72.
72. Okay. Then it's saying what percentage of students agree that it should be mandatory. So how many of those agree?
53.
So what's 53 out of 75? 72, sorry.
0.73. Well, actually, 0.7361.
And when I convert that to a decimal, I get
73.6%.
perfect.
Miss Lopez, A was a typo, right?
A should not have that little dot in the front. It should just be
Yeah.
4.1. Yeah. Questions, comments, concerns? I think that might be the last one. Yeah, that was the last one. So any questions, final questions on frequency tables and relative frequency tables? Okay, moving right along. Now we're going to talk about scatter plots. But before we get into it, does anyone remember what correlation and causation mean?
No idea.
Okay, so I'm going to give you guys an example. Let me think. Okay, in the winter, I'm thinking about this because I'm going to be with my family for Christmas, and that's in New Jersey. So in the winter in New Jersey, the leaves fall off the trees, right? Now, what causes the leaves to fall off the trees?
Because it's cold and
Because
The
it's cold. Right?
weather.
The weather causes the leaves to fall off the trees, right? That is causation. The weather getting cold causes the leaves to fall off the tree.
oh,
Okay, so that's causation. Now,
I was overthinking.
correlation, here's an example. What if I said the leaves fall off the trees because it's November? Would that be true or false?
False.
Does the fact that it's November or December or January or whatever cause the leaves to fall off the trees?
No.
It's the weather.
It's the weather, not the time. Okay. So the time, even though it does fall off the trees when it's the winter or when it's like the months of winter, so October, November, December, even though that's true, it's not a causation, it's a correlation. Because they're to be correlated kind of means like they're related. Time is kind of related to the weather outside, right? Because at certain times it's going to be certain weathers, but it's not directly causing it to happen. Okay, so causation is like cause and effect. Something physically makes something else happen. And correlation means that two things are kind of related to each other, but it doesn't mean that one is forcing the other one to happen. Okay, do I have any questions on what that means? Okay, so here is the most important thing to remember. This is going to be an easy question if it comes up. You just have to remember it. Correlation does not mean causation. They don't mean just because something's related doesn't mean it's going to cause or force something else to happen. Just because it's wintertime doesn't mean that the time is causing the leaves to fall off the trees. Okay, so for this one, answer choice B, that's an easy answer on the test. Correlation does not imply causation. And that, I promise, if you see it, it'll look exactly like that. Correlation does not imply causation. Do I have questions on that?
It was C.
And that's not actually true, right? Because like I said, time is like, it is related to weather. Time, as time passes, weather patterns change. So they are related to each other. They just don't, it doesn't mean that time is going to cause the leaves to fall off the trees. It kind of like skips a step, which is weather. So that's why they're not unrelated. This is false. They're not unrelated. They are related, right? Do you guys agree time and weather are related?
Yeah,
Yeah, right?
because they both like have to do with something happening over a long period of time.
Right. Even in one day. I mean, what was the weather when you guys woke up this morning? It was like 50 degrees out. But
Yeah.
what's the weather now? What is the weather now? 77?
It's kind of like, yeah, it went up.
It went up. Why did it go up?
The sun.
The sun. And what all of that is related to time passing, right? As the day goes on, the sun gets higher, it gets warmer, and then that's why the temperature goes up. So they're related. Time and temperature are related, but does time cause, I don't know, does time cause the leaves to open, the flowers to open up when it's warm? Does time make that happen?
No.
No. So I guess here's something. Time leads to weather changes. which leads to flowers blooming. Sure, let's go with that. But so all of those things are related to each other, but does time go directly and cause the flowers to bloom? No, it skips a step. Okay, so that doesn't mean they're unrelated. They're related to each other, but the sequence of events is important. You can't just say that time causes the flowers to bloom, because that's not true. All right, so that's that. Here are some examples. So which description is a causation relationship? So which of these is when one thing causes the other to happen? Read them
Miss,
through.
I know it's definitely not A, because that doesn't make sense.
Yeah, that does not make sense.
For real.
Okay.
It's definitely not B either.
Mm-hmm.
C either.
Right, because that's how you can't.
Yeah, like just because there's a certain number of students in a class doesn't mean that causes another number, I don't know how to explain myself. Never mind.
The amount of students in the room isn't going to cause you to need glasses. Your eyes are going to cause you to need more glasses.
That doesn't. You could
What about
just read that.
the number of questions
that
that you
sense.
answer
That
correctly?
one makes sense.
Yeah. The number of questions you answer correctly is related directly. It definitely causes your score. So there's causation. Now, are any of these correlation? So remember, correlation means that maybe one is not causing the other, but maybe it does make sense that they might have some sort of relationship.
Maybe
For
B?
example, I was going to explain A really quick. So for example, as you get older, what are the chances that you might get more siblings? Especially if you're the firstborn. So like if I'm the oldest child, if I'm born first, as I get older, I might have more siblings because my parents might have more kids, right? Now, am I causing those kids to get born? I most certainly
No,
am not.
definitely not.
However, there is a correlation, which is that as you get older, the number of siblings you have increases maybe a little bit. So there's a slight relationship, but that doesn't mean that I'm the one causing my siblings to be born. Okay? So that's the difference. Correlational means that maybe there is some sort of pattern, but that pattern doesn't mean that one is causing the other one to happen. I think we might see some good examples of that soon. Okay, so now we're going to get to scatter plots. This is one example of a scatter plot. What do you guys notice about it that might be similar to something
Everything
we've
is
seen before?
scattered.
Yeah, all those dots, it sounds exactly like what it is. Those dots are scattered all around. Now, does it look similar to something we've studied that we know really well?
Like
Graphs,
Mhm.
functions.
Functions, for sure. What type of function does this kind of look like it?
exponent.
No, I think linear.
Oh yeah, linear.
Linear, yeah, because most of these dots seem to be traveling
Down.
downward, right? So they don't follow a perfect line, but they seem to follow a decreasing sort of pattern. So that's what scatter plots are. Scatter plots can look like a linear function, or they might not look like a linear function. And the thing is, the closer they are to a linear function, the stronger that relationship is. So I'll say that one more time. The closer it is to being linear, the closer it looks like a straight line, the more it looks like a straight line, the stronger that relationship is. So would you guys say that this is a strong relationship or a weak relationship?
Weak.
I think it's strong for the most part.
So yeah, take a look at those dots. Are they like pretty close? I mean, they're never going to be perfect. Don't expect it to be perfect. But would you guys say they're pretty close to the line or like super far away, like no way?
Oh, yeah, they're pretty close.
They're all, yeah, they're kind of like getting in there. They're close.
Except for that last one. I don't know where
Yeah,
it's
that
going.
last one is a little bit, what would you call that? There's a word for that.
The
Uh,
outlier.
Yeah,
dang it.
this might
It's
be an
kind of like that
outlier.
duckling that always gets lost forgetting the jacket.
Yeah, exactly. You can always see, you point them out. They're very obvious. So here's, I do have an outlier, but everything else is kind of following that line. Now, we've determined that it is going to be strong. So it's not these two, but is it going to be positive or is it going to be negative?
Negative because it's going down.
Perfect. All right. That's exactly what we do with these types of problems. So we're going to determine if it's strong or weak, and then if it's positive or negative. Who would like to read this one?
Me.
Go ahead.
A linear model shows that the relationship between the numbers of grocery items purchased and the total cost of the grocery bill has a correlation coefficient of 0.97. Which statement about the variables is true?
Okay, so here we're going to talk about correlation coefficient. Okay, I'm going to make a little table. It's going to be a little bit small, but hopefully we can make it work. And this is a good thing to kind of copy into your notebooks. So we already know we can either be strong or weak, and you can either be positive or negative, right? The correlation coefficient is a number that kind of tells you how strong something is, how weak something is, how positive or how negative, okay? The stronger you are, the closer you're going to be to positive one or negative one. Okay, so a strong positive relationship is going to be very close to positive one. A strong negative relationship is going to be pretty close to negative one. A positive weak relationship, so if it's pretty weak, it's probably going to be around like 0.5, close to positive 0.5. And a negative weak relationship is going to be pretty close to negative 0.5. So that's what those numbers mean. So you got to, when it tells you what the correlation coefficient is, you have to look at that number and what is that pretty close to for ours? Yeah, it's
Positive one.
Positive.
pretty close to positive one. So I know that it's a strong relationship and it's a positive relationship. So now take a look at our answer choices. And which one looks the best? Remember, just because you buy more, this is not a causational relationship, because if it was causational, it would be one. It would be positive one. It would not be anything less. So it's not causational, so be careful for that.
Um,
And maybe we can eliminate some. So are there any answers that you guys can eliminate?
C.
Definitely C. Is there another one? Just because I bought more items, does it mean that I'm going to have a higher cost? For example, if I add one more item to my cart, let's say I add one single fork versus 10 pounds of salmon, which one's going to be more expensive?
definitely the salmon. It would also taste better.
Now, what if I put 10 forks versus 10 pounds of salmon? One single 10-pound salmon. On the one hand, I added 10 things to my cart, right?
Yeah.
10 items were added, and my cost only went up a little bit. But on the other hand, I added one single fish and my cost went up a ton. So just because I add more things, is it 100% causing my value to go up?
No.
No.
No. So I can't say that it causes a higher cost. You can't say that because it's not always true. It most likely will, but it's not 100%.
I think B is wrong too because sometimes there's like really expensive things. Like let's say you spent $30, and you might infer that you might think it's like you bought like 5 items or something, but sometimes it could be that you bought 2 items.
Yeah.
That doesn't mean anything.
Exactly. So again, you can't say that this is true because it's not entirely always true. So the only thing I can say, even though I wish I could say that it's going to be 100% always the case, I can't say that. So the only thing I can say is that there's a strong relationship, which is true, right? We already said it is strong and positive, and that is correct. So D is the only one that I can definitely say. It's a little bit tricky. You always have to sort of think it through. And especially if it's a real world problem, you can always put yourself in that situation and think it through that way as well. Which scatter plot represents the data that would be best modeled by a quadratic function? So which of these follows closely to a quadratic function?
Mm,
I think maybe C.
C. Yeah, C.
Yeah, let's take a
Yeah.
look. Yeah, what does that almost look like it could be? If it wasn't quadratic, what would be the other option for that one?
Exponential.
Exponential.
Yeah, but since it's asking for quadratic specifically, we know it's probably C because the rest of them look like what?
Linear.
Linear.
Yeah, that's linear. That's
I was
pretty
kind of
linear.
confused, but like it kind of looked like half of a parabola, so
Mm-hmm.
that's what
Yeah.
I just
It's
thought.
kind of like the other half is over this way.
Yeah, on
Yeah.
the negative side.
Mm-hmm. Good.
Oh, and it starts at 0 too. Oh wait. Oh no, yeah.
Yeah. Okay. Now, these are also good graphs to look at because that's going to just to kind of make sure we understand which one has a stronger relationship, A or B?
A.
Stronger.
A.
A.
They're
Good.
way
It's
closer
a strong
together.
positive relationship, and B is a kind of weaker, but it's still kind of strong.
Yeah,
But
it's not that bad, but it's not as strong as A.
it's normal.
And this one, A would be positive and B would be
Negative.
negative. So what would be a good correlation coefficient for A?
Positive 1.
Well, it's never going to be it's not never going to
Oh,
be
yeah,
exactly 1, but how close can we get?
Maybe
Like, give me any number. It doesn't have to be perfect. Like 0.95?
maybe. Because it's like really close, but it's not exactly.
Yeah. What about for B?
Probably
I think like 60. I don't know.
60 is actually too far out. I wouldn't say
Oh.
this one's weak. It's still pretty
Yeah.
strong. So like 0. I was thinking like 0. Maybe 81,
yeah.
but it's going to be negative because it's negative. What about D? Is that one compared to A and B? Which one's the
D,
strongest?
obviously.
D.
They're
D
basically
is
all
even
straight
closer.
lines.
Yeah. So what would be a good correlation coefficient for D?
0.99.
Would it be positive or negative?
Negative.
Oh, negative. Never mind. My bad.
Good.
Haha.
So there you go. That's correlation coefficient in a nutshell. Since C is quadratic, it kind of works the same way. So we can also do one for that, but we can pretty much, I'm not going to do it right now because that doesn't matter too much. All right, here we go. Select all of the values of a correlation coefficient that suggest a strong linear relationship. Select all.
Is it asking for specifically positive? No, right? No, no.
It's not.
Okay.
Yeah. So it could be
I think-
positive or negative.
I think A and E.
A and E. Good. Those are the only ones. because this would definitely be weak. This would be like weak AF. And what's 0? What do you guys think?
It's
Maybe
I don't
like
know.
um
I think that means that they're just scattered all over the place with no pattern, no order. They're just like
Exactly.
there, like floating.
like they're in space.
Yeah, 0 is like a sky full of stars. That has no relationship whatsoever. Okay. All right. Who would like to read? You guys are doing really well today. I think this is great. This is really good.
Me.
Go ahead.
Wait, does anyone else want to read? Okay. Juan collected data on the number of hot dogs sold at a hot dog stand each hour one day and the number of cars that drive by the stand in that hour. His data are shown in the table. Based on his data, which conclusion can Juan make?
Okay. So his data is, does it look like in order or does it look kind of messy? You're right, Perla. I know I should call on people, but I'm so lazy. And
No,
listen,
miss,
if they're not going
do
to
it. It's for their
participate,
own good. It's for their own good.
okay, fine. Daniel, is this data in a nice, neat order, or should I maybe put it in a better order?
Put it in a better order.
Yeah, it's kind of all over the place, right? So we can basically treat this like like an X and Y table, like a chart. What I'm gonna do is I'm just gonna rewrite these numbers so that they're in a better order. So on the X column, which of those values should I put first? 0. Good, Jalen. So 0 and 11 should go first. What should come next? 9 and 32. After that, 21 and 56. Okay, so that's already good. And then, good, 24, 62. And then finally 30 and 73. Okay, so now we're going to kind of ignore the ones on the outside and just focus on the ones that I put in the middle. And now let's read our answer choices. An increase in cars is associated with a decrease in hot dog sales. What do we think? Yes or no? When the cars increase, as you add more cars, does the number of hot dogs go up or down?
Uh,
It goes up. Good, Emily, Jalen, good job. Yes. So this is false. That's not true. An increase in cars is associated with an increase in hot dog sales. Okay, that's what you guys just said, so I'm going to keep that one there. An increase in cars causes a decrease. I already said decrease. That's no bueno. And then finally, an increase in, I think that was supposed to have the word cars. An increase in cars causes an increase in hot dog sales. So B and D are kind of saying the same thing, but D is implying that the number of cars will cause the number of hot dogs to go up. Is that true or false?
False.
False. Again, or don't be fooled by that word. Just because more cars went through does not mean that more hot dogs were sold. That doesn't necessarily work out every single time. So B is the one that it's associated, it's correlational. There's a correlation, but there's not a direct causation. Nice job, guys. We are almost there. Let me see.
Ms. Lopez, I
4
think we're
more.
gonna need a pep talk all together because I'm not feeling nervous because I usually only feel nervous the day of. I don't
Mm-hmm.
know. I don't feel the effects before. I feel the effects in the moment. So,
I
wanna be
will. You
pep
know,
talk.
I will definitely give you guys a pep talk, and I'll see if I can maybe be virtually there on Monday. I'll see if Mr. St. Rose can put me up on the board or something.
Okay.
Not the whole time because I have other classes to teach, but at least at the very beginning.
Miss, look at Jalen being a party pooper. Wait, Miss, I had a question. Were we gonna do this in your classroom? I was like, in the classroom or a computer lab?
Computer lab,
Miss-
probably room 40.
Oh, okay. So on a different computer that's not ours.
Mm-hmm. Yeah, you
Okay.
don't need to bring your laptop unless you're staying. I think Jalen, your mom said you're staying. Samaj, you might be staying. So you guys do have to bring your laptop so that you can go to your classes afterwards.
Miss, I'm forcing Jalen to come with me to the robotics room to fix our robot. I'm holding him hostage.
Okay. As long as he gets some work done, I think that's fine. All right. The scatter plot shows the price and cents of a postage stamp used to mail a letter in the United States for the years from 1958 to 2014. Also shown is the line of best fit to model the data. So here's what we have. We have a line of fit or line of best fit. What that means is basically what happens is all of this is obviously a scatter plot, right? Those dots are not perfectly on the line, but what that line represents is like the average. It's kind of like it cuts through right through the middle, through the most amount of points, and it's the line that all of those points are kind of close to, okay? So that's the line of best fit. The equation of the line of best fit is y equals negative 0.71 plus 0.86x. What does that look like to you guys?
The equation,
Mm-hmm.
it looks like y equals mx plus b.
Yeah, it sure does, and it sure is. What's wrong with it though?
It's in another order.
So
Like they're
let's
so
rewrite it.
lazy, they don't want to fix it. They want us to do everything for them.
Let's go ahead and do it for them. So I have y equals 0.86x minus 0.71. Great. And okay, cool. Which statement best describes the model? The model being that equation. That equation is the model. Okay. The model estimates an increase on average of 0.71 cents per year in the price of a stamp. True or false? True or false?
False.
False. What is 0.71? That's not the rate of change. That's the
Y-intercept.
y-intercept. Good. The model estimates a decrease on average of 0.71 cents per year. Again, 71 is not the
False.
slope.
It's the y-intercept.
What about C? The model estimates an increase on average of 0.86 cents per year on the price of stamps. True or false?
Maybe. True.
Maybe. We can leave it.
Miss, I'm kind of confused.
Why?
Where is the y-intercept on here? I don't see it. I just see it starting from down below.
Yeah,
Oh, it's negative. Never
it's
mind. Don't
negative.
understand.
So this kind of continues on and it's hidden, but it's there. So we're going to keep C. Now let's look at D. The model estimates a decrease on average. Okay, so there's the difference. Is it an increase or is it a decrease?
I think it's an increase. Yeah, it's an increase, right?
It is, yeah. That's a positive slope. Okay. Now,
Miss, I
this
think Jalen
question
needs help.
is continued from the previous slide, okay? So the previous slide, we're still thinking about this graph and that equation. Guys, I need you to focus. We're almost done. Here we go. The correlation coefficient for the variables for the year and price of a postage stamp is 0.994. That's the correlation coefficient. What is the best interpretation of that coefficient? A, the relationship between the variables is weak. True or false?
Wrong.
Wrong. Definitely wrong.
Definitely wrong. So is B, because that also says weak.
Yep.
Okay, C.
Strong.
The relationship between the variables is strong, good.
Mhm.
And as one variable increases, the other variable decreases.
I think that's wrong.
That's false.
That's positive,
Because it
isn't it?
doesn't decrease, it increases.
It increases. Good.
So it's D.
So
Yay,
it's
that
D.
was quick.
Yeah, not too bad.
Miss, what happened to part B?
I skipped it because it had to do with something that's not really on the test, so it's fine.
Okay.
Yay.
All right, last one, I think, of this problem. According to the model, what is the best estimate of the year when the price of a stamp will first reach 75 cents? Okay, so again, I'm going to write the equation down. Oh, let me write it with the correct. Okay, so it wants to know when will the price reach 75 cents? Now, which variable represents money? Is it the y or the x? Which variable
you repeat?
represents money?
Oh.
Variable represents money. 0.86?
Which variable, which
Oh,
letter
variable.
represents money?
Is it Y?
Y, yeah.
Why?
It says Y
Because
is
the
price.
predicted price cents.
Exactly. So y is cents, okay? So what I can do is I can plug in 75, but will I plug in 75 for x or for y?
For Y.
For y, good. And we're going to solve for x. Let's do it. I add 0.71, 75.71 equals 0.86x. I divide by 0.86. You may use your calculator. What is 75.71 divided by 0.86?
88.034.
So about 88. Now, 88 what? What does x represent?
Cents?
Years.
Oh, years.
Years since 1958. So if 88 years have passed, what year am I in?
We're in the year 2046.
2020. Oh.
2046. 88 plus 1958 gives me 2046. So there you go.
I wonder what year 2046 will be like.
There will be flying cars.
I hope we're still here. I mean, what?
For real?
I doubt it.
All right, here we go.
Wow.
Last one of this is our very last problem ever for this. Which function best fits the data represented by this scatter plot? Okay, I have a scatter plot. I need to fit the data to it, and I have a few options. So what I'm going to do is I'm going to kind of graph each option. A, y equals 1/2 x plus 2. So I started at 2. I go 1/2, 1/2. It's going to be like this. So there's A. Here's B, y equals 2/3 x. Technically, this is plus 0, so the y-intercept is at the origin. 2/3, 1, 2, 3. Here we go. Okay, there's B. Now we got C. Y equals 3/2 x. 1, 2, 3, 1, 2. There's C. And then finally D.
Yeah.
Y equals
Miss
2x.
Lopez.
Yes.
Carlos' laptop died.
Okay. It's a good thing we're almost done.
She can still hear you though from mine.
Okay, cool. All right, so which of these is definitely in or out? Which one's definitely out? Which of these definitely does not fit right?
C.
Yes, C is out. What else?
A. Actually,
Remember, we're looking for the one that kind of cuts through the middle of all those points. I see Jalen says that D. I would argue B can still be in because B looks like it's cutting
D
through the
is
middle.
out. D is it's going all over the place.
But D is definitely out. I mean, that's definitely not even.
It literally only touches one by
Yeah.
a little.
So I'm gonna get rid of those. All right. So between the blue line and the red line, which one seems to follow the pattern of the points best?
The red one.
I think the blue one kind of. Actually, I don't know. One between them.
Here's
And then-
something to keep in mind. You want to have about the same amount of points above the line as below.
Oh, okay. So red then.
Red.
Yeah,
Yeah.
red is
See,
definitely
Tyrone's
lower.
always right.
So A was our answer for that. I'd say that's pretty good too. All right, guys. So that's it. Wow, I'm gonna miss these days.
Oh no, Miss. This is gonna be scary, Miss.
All right.
But I'm sure I'll do great. We
Good.
have the best teacher ever, and we have big brains. We've
We
made it
do.
here. We have biology. We have done geometry. We're doing great. Okay.
You are going to do amazingly. And I'm still going to see you tomorrow and or Sunday if you want to come to both days. So this is not the end of things. Remember to finish your homework tonight so that if you have any final questions on those problems, you can bring them to me tomorrow. Also, tomorrow I can answer questions about the day, what the test will look like. So like all those questions you asked today about do you need your ID, do you need your uniform, all of those things, I'll answer them as well.
Ms. Lopez,
Yes.
can I do the questions with you tomorrow? Or I mean Sunday, because tomorrow I'm not gonna be able to. Because the questions I left for last are the ones that are like the hardest to me.
Have an answer, have what you think might be the answer.
Okay.
And then so you're not going to skip them, you're going to do them so that I can grade it.
Man.
Mhm.
No, I'm gonna get them wrong. It's like 10 of them.
You'll be fine.
Okay. No, I won't.
You'll be just fine. All right, y'all. Good job today. I will see you tomorrow or Saturday. I mean Sunday. Do your
Bye,
homework. Goodbye.
Miss. See you Sunday.
See you Sunday.